Hi, welcome back to another video. Today I'm going to be going over hydrogen fuel cells and the other part of C5 that I forgot to cover in the C5 overview video, but I want to do this part in a bit more detail anyway, so it would have been worth doing it in this video because you normally get a 6-mark question on hydrogen fuel cells comparing to rechargeable batteries. So you need to know how to do this, and I need to explain it in a bit more detail. But first, we're going to go over a recap. An exothermic reaction is heat or thermal energy transferred from the chemicals to the surroundings. So here we can see it's transferred from the reactants to the surroundings. Overall energy decrease, and endothermic heat or thermal energy is transferred from the surroundings to the chemicals. So overall, there is a heat increase. So the thing we commonly refer to as a battery is actually just a cell. So this is just a cell. We commonly refer to it as a battery because we have it here, but it's actually just a cell. Now this is a battery. A battery is more than one cell. A cell is one battery. So a cell is one battery like this. A battery is more than one cell like this. So this leads us on to rechargeable and non-rechargeable batteries. So we'll start with non-rechargeable batteries. So in a non-rechargeable battery, the chemical reaction that produces electricity is the chemical reaction that produces electricity is dead once it's used up. It's not rechargeable once the reaction has produced electricity. It's dead. It won't work again. So we can say if you get a question saying why are non-rechargeable batteries non-rechargeable, or why do they only have a battery life of one life, it's because once the reactants are used up, the battery is dead. There is no electricity that can run through once those reactants are used up. However, in a rechargeable battery, there are more reactants. It's a reversible reaction. So it's a reversible reaction, meaning that I'm trying to word this as most scientific as possible. There is a forward reaction and backward reaction. So once if we have electricity going through the reactants like we do in non-rechargeables, it will create the products. In a reversible reaction, you can pass electricity through the products to go back to the reactants. So this rechargeable battery, once we get to the products, it flows electricity back through, recharging the battery, so it's rechargeable. Now we move on to hydrogen fuel cells. So in a hydrogen fuel cell, we just have hydrogen gas reacting with oxygen gas to produce water. So in a hydrogen fuel cell, we have 2H2 because that's 2 hydrogen plus O2 to give us 2H2O. So that's what we have in a hydrogen fuel cell. Now, in hydrogen fuel cells, there's a large amount of energy needed, large amount of energy released, which means that it's exothermic, and this would be an advantage. And that would be an advantage of using a hydrogen fuel cell because it doesn't require, well, it requires energy, but it releases energy during the process. Another advantage is water is the only product. So water is the only product, which means that there are no carbon emissions, which is an advantage because it doesn't impact or have any bad effect on the environment. These are all advantages. However, there are many disadvantages with this, such as the production of hydrogen. It is always the production by fossil fuels or electrolysis, which, as we know, electricity is produced by fossil fuels. So whichever way we look at it, it's going to use fossil fuels. Hydrogen fuel cells uses fossil fuels, which impacts the environment massively. Also, hydrogen is very hard to obtain and has to be stored in large tanks, which is very expensive. It is very expensive, so it's very hard to obtain it. And even if we do obtain it, it's very expensive to use and store. Also, it's hard to find, and also this doesn't work at low temperatures. This is the biggest issue because it requires a lot of energy, which is very cost-worthy. Very high energy, very cost-worthy. So overall, I think that the disadvantages outweigh the advantages. But this could be a typical 6 marker. Compare hydrogen fuel cells with a lithium rechargeable battery, and you've got to use these advantages, disadvantages. You may get a table showing you some data, and it may say use the data as well, but also use this knowledge, because this knowledge will get you the 5-6 marks. At the positive electrode, we are going to get 4 H ions, so they're going to be H plus ions. 4 H plus ions, and we're going to have plus the O2, then we're going to have plus 2 E minus ions, because electrons are minus and negatively charged, which is going to give us which is going to give us 2 H. And that's supposed to be a capital A. See, I do things right all the time, just not when I'm actually trying to do stuff. And at the negative electrode, we're going to have 2 hydrogen plus ions plus the 2 E minus, which would give us just hydrogen. Oh no, that's supposed to be hydrogen H2. So hydrogen plus 2 will give us hydrogen plus ions. And that's all of C5 covered. That is hydrogen fuel cells. You are going to need to know this because this is definitely going to come up in the exam. We see this year on year, so revise it.